Hey guys, welcome back to another Law of Conservation of Energy problem with physics in the flesh. A 108 kilogram crate starting from rest is pulled across the floor with a constant horizontal force of 345 meters. For the first 20 meters, the floor is frictionless, and for the next 20 meters, the coefficient of friction is 0.29. What is the final speed of the crate? So this problem, the first way I actually thought of solving it is through kinematics and dynamics. But right now we're doing energy and work problems. So what I decided is I'll do two videos. This one is going to be solving it through kinematics and dynamics. And the second video, video 113, which will be posted tomorrow at 12 noon, is going to be solving it using the work kinetic energy theorem. Okay, so for this video, honestly, it comes down to the same thing. You're solving it. It's almost the same amount of work. You're just solving it with two different principles. Okay, so let's solve it using kinematics and dynamics first. Now, the way to solve this problem and approach it is that you have to split this up into two separate pieces. The first 20 meters where you have a frictionless floor and the second 20 meters where you have friction. Okay, so first 20, second 20. Now, because I have friction in one and no friction in the other, I'm going to draw two free body diagrams to represent the situations. Okay, so here's my floor, here's my box. In the first 20 meters, here's the box in the second 20 meters. Okay, now, some forces are the same, obviously, in both cases. We have force of gravity due to its weight. We have the normal force due to the table pushing up. And we've got the pull force going forward. F pull, F pull. Okay, the only difference is in the second 20 meters, we also now have a frictional force going back. It is kinetic friction, but in this question, it doesn't make that distinction. It just gives you the coefficient. You just assume that's kinetic. Okay, so first things first, let's do the easy side without friction. Okay, so we are trying to figure out what the speed is going to be at the end of this time. Okay, so we're trying to find the speed here. Let's call that V3, right? So in order to do that, we need to have, well, we know the initial speed actually, right? It's starting from rest. So V1 is equal to 0. We need to find the final speed as it reaches the end of the 20 meters and it starts the second 20 meters. So we'll call this point V2. So V2 will be the final speed of this section and the initial speed of the second section. Okay, that's how we're gonna solve this problem. Okay, now V1, V2, we know the distance is 20 meters, so the missing element here is acceleration. I've got a free body diagram, so I'm going to go ahead and use Newton's second law. F net equals ma. And specifically, I'm solving for acceleration here, so divide both sides by mass. A is equal to F net over m. Okay, so the net force here, we're in the vertical direction, normal and gravity cancel, it's done. But in the horizontal direction, you're looking at the pull force. Okay, that's your net force. So I'm going to say acceleration is F pull over mass. F pull is 345 newtons. Okay, the mass is 108 kilograms. Simply plug it in your calculator and you're going to get an acceleration of 3.194 meters per second squared. Okay, so you've got the acceleration. You know V1 is 0. Look for V2. Distance is 20 meters. Okay, so at this point you just have to plug in. So V1 is 0 meters per second, distance 20 meters, and we're looking for V2, right? Okay, so we're going to use that really simple kinematics formula to find V2. You know what, let's do that up here. 2AD equals V2 squared minus V1 squared. We're looking for V2. Well, V1 is 0, so that actually makes things a lot easier. V1 is 0, V2 is equal to the square root of 2AD. Plug in your values. 2 times 3.194 meters per second squared times 20 meters. Punch that in your calculator, you are going to get V2 is equal to 11.3 meters per second. Okay, so that is a very important number. 11.3, that's the speed we have right here, finishing the first 20 meters, starting the second 20 meters. Okay, so let me actually go on the side here. I kind of went into my second side there. Okay, so now we're dealing with V2, V3. The distance is still 20. So how do we incorporate the fact that there's friction now? Well, the fact that it's asking for a V3, the speed is changing, right? It's not constant. So there's going to be an acceleration, and that acceleration is different than the one here because the net forces are different. So that's where we want to take a look. So for the second 20 meters, we're going to say V2 is 11.3 meters per second. We're looking for V3. So we're going to use 2AD equals V3 squared minus V2 squared, right? We're looking for V3. So it's going to be V3 squared equals 2AD plus V2 squared. What's A? That's what I was just mentioning. That's what we need to find. Okay, so we're going to use Newton's second law again. F net equals MA. In this case, in the horizontal direction, we have F pull minus F friction. That implies a positive direction to the right. Okay, so F pull minus F friction equals MA. Okay, now friction is mu K Fn. And the normal force in this case is equal in magnitude to the force of gravity. So that's mg. So mu K Fn equals ma. F pull is 345 newtons. Okay, mu K is 0.29. Fn is mg, so 108 kilograms times g, 9.8 meters per second squared. And we set that equal to ma. Okay, so 108 kilograms times a. Let me bring that in a bit. Okay, so honestly, just solve for the left side. It's a simple mathematical expression. When you do that, 345 minus 0.29 times 108 times 9.8, you are going to get 38.064 newtons equals 108 kilograms times A. Divide both sides by 108, and you're going to get A is equal to 0.352 meters per second squared. So there's your new acceleration. Notice it's a lot smaller than the one you had over here, the 3.1, and it has to be because there's friction. So you take that, you plug it in there. So V3 squared is equal to 2 times A, which we just found to be 0.352 meters per second squared, times distance, it's still 20 meters, plus V2 squared, which is 11.3 meters per second squared. Okay. Punch that in your calculator again, and you're going to get your V3 to be 12 meters per second. Of course, you have to take the square root of this expression afterwards. Okay, so V3 is 12 meters per second, and that is it for this problem, guys. I hope you enjoyed it. If you did, be sure to smash that like button. If you have any questions, be sure to leave them in the comments section below. Otherwise, I will catch you guys in the next video. Hey guys, that's it for this episode. If you enjoyed it, be sure to check out some of my most recent videos posted over there on the right, which you can click on your screen right now and watch. Other than that, guys, I hope you enjoy the rest of your day, and I will catch you in the next video. Is the end screen too long this time? Wait, you're still recording? No! Oh. Gotta move that chair out of the way next time.